Welcome to this manufacturer showcase hosted by NYSERDA's Empire Building Challenge. Its purpose is to familiarize you with new or emerging technologies meant to facilitate decarbonizing our building stock and applicable across entire portfolios. All sessions will be recorded and available upon request, and slide decks sent to all attendees. Each presentation will be 20 minutes, followed by 10 minutes in which the presenter will respond to your questions. We ask that you go on mute until then. And now it is my pleasure to introduce Frederique Pirenne of OhmIQ.
Thank you, Sol. Welcome, everybody. I would like to introduce you to our product ThermIQ, which simply is the fastest, simplest, and most cost-efficient way to electrify commercial real estate. Quickly about ourselves, we are OhmIQ, a company based in South Carolina that started only 2 years ago, but after more than 10 years of research with OhmIQ technology. We are currently a team of about 20 members and growing with engineers, and fully owned by a family office venture capitalist firm called IAG Capital Partners. The product that we're presenting today is called ThermIQ. As I mentioned, it is the fastest, simplest, and cost-efficient way of decarbonizing your buildings or electrifying them. And it's basically more of a thermal battery that is used as an addition to your current heating solution, or specifically even better, heat pumps that uses the technology to heat in the places where and when it's needed for commercial buildings. It's mainly used for commercial buildings, could be used for multifamily homes, but it is commercial buildings that we're mainly targeting right now, which could be schools, offices, or hospitals, for example. It's a thermal battery, as I said, that heats up the water and tops it up specifically during those days where now large high temperature heat pumps are required, or let's say the about 500 hours per year where heat pumps or other heating systems are struggling because the outside temperature is too cold. In those cases, our solution will take data and heat when and where is needed, giving good results in general. As I said, OhmIQ is the fastest, simplest, and most cost-efficient way of taking your building to electrification. Fastest simply because it works with existing heating systems. The system is optimized if it's used with off-the-shelf heat pumps, which means that you don't have to pay for high temperature heat pumps. But it can also be used as a standalone unit, which means that it can be used for regular air heating or heating using steam. But hydronic systems is a preference. It's a relatively very easily installed product as a standalone for sure. If you want to implement it into a hydronic system, it only takes 4 steps. Those 4 steps are in the appendix of this presentation that will be sent out to you, really underlining how easy it is. We have an operating system that uses a lot of data and collects data and works with that together with the systems that use the steering system of the building. Again, it could be either on-premise or in the cloud, based on what your preference is. And it's integrating with the largest systems that are currently available in the market. Cost efficient because, as we said, in order to cover the entire peak usage over the year when it's really cold outside, you can just use off-the-shelf heat pumps, and there's no need for high temperature heat pumps. For the modeling that we've done for the buildings that we have, that came up to an average of about 23% savings in CapEx. For one of the buildings that we had in New York, that would be around 6 to 7 million in savings. Also, there's over 8% in savings in operational expenditure, mainly due to the decentralization of heating only when and where it's needed. But also, since it's easy to install, there's no need to eject tenants. You can install it when the tenants are occupying the building, unlike other solutions to reduce greenhouse gases, such as facade changes or complete renovations of heating solutions. What makes our technology different? First of all, we use what we call OhmIQ technology. OhmIQ technology has existed for more than a century, but has never really been commercialized for the simple reason that it requires a lot of control, which wasn't available, but now it is. OhmIQ technology basically means that we bring power directly to the water using electricity, eliminating the means of the resistance heater. Since there is no resistance heater, there's no scaling, meaning that we have almost zero maintenance, or actually zero maintenance, when it comes to the heating system as such, making it a lot easier, of course, also to keep it going. There's no burnout, so that can take a long time before, well, actually, probably something else will break before our system breaks. It provides a faster speed to temperature because we cut out the middleman. The electricity and the power is going straight into the water, which means an increased energy efficiency. And again, since there's no scaling, that energy efficiency is sustainable over time and doesn't taper off as the system scales up. That's one side of the equation. The other side of the equation is obviously that we use an AI integration. And here are some of the data sources that we use, of which the most important part is occupancy controls. So by talking to the systems that are in the building, we know when and where people are there. We use sensory controls as well, and weather forecast that we have, which means that we can start heating up all of the thermal batteries in advance of what is needed. Also eliminating then electricity usage during peak hours when everybody else will have to start heating their offices and so forth. And then we can also even control which part of the building we heat at what time and so forth, depending on how the sun moves and all those kind of factors that come into the equation. That is connected to machine learning, so that also, for example, specifically the occupancy, because the occupancy is the main driver of heating and energy usage and so forth. In order to continue then following that occupancy, we can learn as to how, when, and where we would have to do that in order to go that in advance, right? The easiest way that we thought to explain it to you is to show it to you. So we're just going to show you a small video now that I hope would work then in that case with the link.
We're seeing a blank screen.
Yes, the link doesn't seem to be, well, the link works because it opens up in my browser, but it doesn't necessarily open up in this. Basically, what happens is that if we connect our system, which is a thermal battery, to a convector, a fan coil, or anything else, it charges up in advance based on the data that we get. And when heat pumps or other systems use the maximum temperature that they can reach or will reach based on the energy usage that you want to put in, our system will top that up. And by topping that up, it means that it will take 2 or 3 runs of hot water past the convector or past the fan coil, only in those places of the building where it's required to put in additional heat in those places, making it comfortable, of course, for everybody who is there. The fact that we heat up faster also means that if there is a required necessity for doing one additional run, because we're not at the desired temperature, our system can do that relatively simply, right? There is an interesting video that shows this entire part. I do encourage you to look at it once you've received this presentation. That's the explanation, but what does that say in numbers, right? So we've been modeling multiple office buildings, existing office buildings in New York, for which we saw that there was a significant energy reduction. I would like to point out this works. I would like to point out just about above the number 5, there's a very small green zone, and that's basically the electricity consumed by ThermIQ. But during those hours where there is a required increased need for energy for heating, that's where we have a huge output. So there's a relatively or very, very small input, as you can see here, for the energy delivered by ThermIQ above the red line, as you can see, from slightly above 10 all the way up to the full thermal load that is required during those limited hours per year that is required. At this point, a lot of systems will tell you to install high temperature heat pumps or other solutions throughout the entire year, which will have an impact on, again, your CapEx, but also your operational costs throughout the year, which we basically take away at this point. It's also a significant energy consumption reduction, considering the baseline that we use for this building. This building was currently running on gas boilers. So those gas boilers have then been exchanged by a readily available off-the-shelf heat pump in combination with our ThermIQ solution. What is then next? What are we hoping for to obtain now and also within this meeting? So basically at this moment, we have built the system. We're undergoing certification at the moment, and the product will be or is planned to be in market somewhere next year. Keeping in mind the timelines that there are also for building upfits, planning, and so forth. We are currently involved, being integrated in the plans for 3 particular projects. One is a community center in New York City, moving from a gas boiler to heat pumps. Other systems are in Boston, where it's always a upgrade to a heat pump system, and basically also facade structure in the case of Boston. Obviously, we would love to hear whether there is more interest to discuss the implementation of our system into your plans, and we are more than happy to collaborate in the modeling of what that would be, given we exchange information and so forth. I hope this was very clear, but I do encourage you to please ask as many questions as you would like, either in the time that we have left, which is basically about 15 minutes, or otherwise there are my contact details that are here. In answering the questions, I did bring 2 of my colleagues, one of them being Neil Gannon, who's our CMO, and the other person being Bruce Hayes, who's our Chief Partnership Officer, who might also assist me in some of the answers in case I don't know all the details. So I do encourage you to answer or to ask anything you would like to know about our product or even OhmIQ technology as such, if that's what you are interested in.
Frederique, thank you so much. If anyone in the audience has a question, if you can take yourself off mute and ask it, and then afterward go back on mute. So the floor is now open.
Hi, this is Murat. So the OhmIQ heating system is integrated to, I guess I missed the first few minutes.
Okay.
Does it inject heat to the existing hot water loop in the central hot water distribution system?
If it's a hydronic system, then yes and no. So basically, there is a loop. We are connected to the central loop. Whenever we feel or we know that the central loop is not enough, we actually will have a bypass of that loop and organize it in such a way that the water that comes from our system passes the convector 2 to 3 times to emit the heat at that particular convector at that part of the building, and then the rest will continue on the parallel loop, as is normal in these kind of hydronic setups, to continue driving, so that we don't spread the heated water across the building, because that would defeat the purpose. So we have a adjacent loop, which is also connected to the convector, where the water passes 2 to 3 times, depending on what the necessity is, to heat up that particular part. That's if it's connected to a hydronic system. If it's not connected to a hydronic system, then it's basically a full standalone loop in itself that then passes over a heat fan coil, a little bit more like a heat exchanger in that case, I would say.
Great. Any other questions from the audience?
Hey, Frederique, I had a question. I guess going to what you mentioned about the heat exchanger, is that how this system would tie into like a existing steam system?
Most likely, yes.
So
I mean,
there is going to be compatibility for, say buildings that don't want to go off steam, like convert to like a hydronic or some sort of electrified heat pump solution. There would be compatibility with steam systems as well.
yes.
But then those parts components of the system to like make that work would be by others, I'm assuming, not by OhmIQ.
What do you mean by those parts that would make that work?
Well, like
Heat
say
exchange and so forth?
correct.
Yes, we will have to look at that setup particularly. Yes.
Got it. Thank you.
This is Lisa Hart in Syracuse. We have public housing buildings. So say you went to a neighborhood geothermal, thermal energy network system, like for a whole neighborhood, you had multiple low rises, mid rises, single family homes, row houses. Would you be able to use the system? Is that compatible with geothermal?
It's definitely compatible with geothermal. I myself live in Sweden, where geothermal and district housing or district heating is more the norm than anything else.
Right.
And we have also been investigating with some of the engineering parts there, where they actually said that this might be a solution for one of the problems that they're experiencing there as well. Because I mean, you have to heat up the entire loop, right? Which is a tremendous amount of energy that you have to pump in. Decentralizing it with a system such as ours could significantly benefit that particular part. We've been mainly doing in all transparency, we've been mainly looking at office buildings. We do believe that multifamily homes is not a problem as well. It's not a problem either. Then when it comes to an entire combination of low rises, high rises, single family homes, I must admit that we will have to investigate that a little bit further, but I'm more than happy to take your contact details and investigate it together with you.
Yes, I was just interested if you were looking into the multifamily housing. So, okay.
Yeah.
Thank you.
Any other questions?
Outside of, I guess, within the U.S. and then I guess outside of the U.S., are there any installations that have been completed and any like case studies or data gathered on how the system performs?
No, unfortunately not.
Anyone else? Frederique, to clarify in your slides, this will now be in market the second half of 2025. Is that correct?
That's what we're aiming for, yes. I mean, there's a couple of elements that we don't fully control. We don't know how long time certification takes, but we are aiming to getting it in market by then, yes.
Great. And following up on Lisa's question, your initial focus on commercial and institutional as opposed to multifamily, curious why you began there, and then also if you see any differences in the transition from the one to the other in terms of taking on multifamily buildings.
Commercial buildings is partially opportunistic. We have developed this this system in collaboration with a consultancy firm that does decarbonization of buildings, and mainly institutional buildings, such as commercial buildings and so forth. We saw also that there was quite a big drive in the commercial buildings, specifically in the states of Massachusetts, New York, and so forth, for decarbonization and specifically electrification. But we have then been looking into as well into single-family homes, multifamily homes. I'm sorry, and it is different, but we don't believe it is. The biggest advantage that we get here is that we get an opportunity for decentralization, and that we can gather data knowing where and when it will be needed in time. That's perfectly doable with a multifamily home. The data that we'll be gathering can actually even be much bigger in a multifamily home, which could even drive up better usage of the product as such. Then we will
Great,
have to
thank
see.
you.
Then we will have to see how that works, because I mean, now if we have tenants, you have multiple spaces, then we'll have to see the benefits for each individual user and so forth. But that's something that we will still have to model in that case.
This is Neil Gannon from OhmIQ. I just want to jump in to support on one of the questions that came earlier with regard to had we product in market. We have run simulations of our product in actual buildings in the US as well. So we've actually gathered quite a lot of really interesting data. So that is something that we can talk about further. I just wanted to kind of, bring that part up. Whilst we haven't installed this great tech yet, we have run the simulations in cooperation with one of our partners, Herbs. So that data is definitely there, and it's actually really interesting what's come back. That's it.
Thank you, Neil. Thank you.
Great. Last call for any questions. All right. Well, Frederique, Neil, thank you so much for your presentation. We appreciate it. We appreciate everyone who attended today, and I hope you can join us for our next